Find zeros of the given quadratic polynomial x square plus 5x plus 6. So in this type of quadratic polynomials, different types will be there just by changing the symbols. So let us observe one by one type of the questions. So first, the given quadratic polynomial is having all the terms positive symbols only. So how to solve this one? Next I will go with by changing the symbols also. So observe this clearly. So first one, x square plus 5x plus 6. We need to take the constant 6 and multiply that with the coefficient of x square. Here before x square nothing is there, so it means 1. So 6 into 1, 6. Now we need to write where this 6 will come. 1 6 are 6, 2 3s are 6, 3 2s are 6 1s are. So only these two are the possible pairs. Now in the given quadratic polynomial, if all the terms are positives, so keep it here also everything as positive. Plus 1 plus 6 plus 7 plus 2 plus 3 plus 5. If we observe clearly, this middle term is plus 5. So this second pair is the correct pair. First term write as it is x square plus 5x. We need to replace with 2x and 3x. 2 plus 2x plus 3x. Last term plus 6 as it is. Now from the first and second term we need to take out something common, x square plus 2x. So easily we can take out x common, then remains with x plus 2. Now from the third and fourth terms also we need to take something common. After taking common, as it is here what we got inside of the bracket, the same we need to get here also. Then what else we need to take common? For that one, observe the third term. Third term is 3x, right? So here already x is inside of the bracket. The remaining is plus 3. So x plus 2, it is there 2 times. So just write it one time. X plus 2 times. Here remaining is x. Here remaining is plus 3. So x plus 3. Now we need to find out the zeros, right? Till here if you find, it is called as factorization. But you need to find out the zeros also. So here x equals to, here plus 2 is there, make it minus 2. Here plus 3 is there, make it minus 3. So minus 2 and minus 3 are the zeros of the given quadratic polynomial. Let us check one more. What are the zeros of the quadratic polynomial x square plus 9x plus 18? So multiply the constant and x square coefficient. Here constant is 18. That 18 we need to multiply with x square coefficient. Here x square coefficient is 1. So 18 ones are 18. In which tables 18 will come? Let us write all those. 1 18s are, 2 9s are, 3 6s are, reverse again 6 3s are, 9 2s are, 18 1s are. So only these three pairs are possible. As I said in the previous question clearly, here all the terms are positive. If all the terms are positive means in this pairs also every number should be positive. So plus 1 plus 18 plus 2 plus 9 plus 3 plus 6. Sorry. Plus 1 plus 18 is plus 19, 2 plus 9 11, 3 plus 6 9. Now if we observe clearly, this middle term is plus 9, right? So this last pair is the correct pair. So write the first term as it is x square plus 9x we can replace with 3x plus 6x plus 18. From the first and second terms we can take out x common, so remains with x plus 3. Now from the third and fourth terms also we need to take something common. After taking that common, exactly we should remains with x plus 3 only, same like here bracket. Now what we need to take common here then? If you observe the third term, that is 6x, right? So here already x is completed inside, the remaining is plus 6. Now if you observe, x plus 3 is there 2 times, so write it once, times, here x is extra, here plus 6 is extra, so x plus 6. Here x plus 3, so plus 3 is there, then our 0 will become minus 3. X plus 6 is there, so x will become minus 6. Minus 3 and minus 6 are the zeros of the given quadratic polynomial. Next, zeros of x square minus 5x plus 6. Now what exactly the difference is there in between the previous two questions and this question? In the previous two questions, all the terms are positives, whereas in this question, only the middle term is negative. So observe this one. A small logic is different, that's it. Remaining all same. Constant is 6. Multiply that 6 with x square coefficient, that is 1. So 6 1s are 6. 6 will come in which tables? 1 6s are, 2 3s are, That's it. 3 2s are 6 1s are. So now, if only the middle term is negative, I repeat, if only the middle term is negative, in the pair, every number should be negative. Minus 1, minus 6, minus 2, minus 3. Minus 1, minus 6, minus 7, minus 2, minus 3, minus 5. Here middle term is minus 5. So this second pair is the correct pair. So x square as it is, minus 5x can be replaced with minus 2x, minus 3x. Plus 6 as usual. Now from the first and second terms, we can take out easily x common. Then remains with x minus 2. Now here also inside of the bracket we need to get the same x minus 2. If you observe the third term, that is minus 3x, already x completed, there remains with minus 3. X minus 2 is there 2 times, so write it once. Extra here x, here minus 3, so x minus 3. Here x minus 2 is there, then x value will be plus 2. X minus 3 is there, then x value will be plus 3. So 2 comma 3 are the zeros of the given quadratic polynomial x square minus 5x plus 6. Next, zeros of the quadratic polynomial x square minus 4x plus 4. Again, same like the previous question, here only the middle term is negative, whereas the remaining all terms are positive. So now, constant is 4. We need to multiply that with x square coefficient. So 4 1s are 4. 4 will come in which tables? 1 4s are, 2 2s are, in reverse 2 2s are, 4 1s are. So only 2 pairs are possible. As I said already in the previous question, if only the middle term is negative, every number should be negative in these pairs. So this should be negative, this should be negative, this should be negative, this should be negative. Minus 1, minus 4, minus 5, minus 2, minus 2, minus 4. Now, this is the correct pair for us because the middle number is minus 4. So write the x square as it is. Minus 4x we need to replace with minus 2x minus 2x plus 4. From the first and second terms we can take out x common, then remains with x minus 2. The third and fourth also we need to take something common. After taking common, again we need to get same x minus 2 only. So for that, if we observe the third term, here minus 2x is there, already x completed, the remaining is minus 2. So x minus 2, it is there 2 times, so write it once, x minus 2. Remaining here x minus 2, x minus 2. Now x value we need to find out. So x value will be, here minus 2 is there, plus 2, here minus 2 is there, plus 2. So 2 comma 2 are the zeros of the given quadratic polynomial. Next question. Zeros of the quadratic polynomial x square minus 3x minus 18. In the first type of question, all the terms are positive. In the second type of quadratic polynomial, only the middle term is negative. Now, this is the third type of question. In this third type of question, again 2 types will be there. One is last term, middle term, both are negatives. And the second one is only the last term is negative. So, let us check how to solve these kind of questions. First type, as usual, constant we need to multiply with x square coefficient. Here constant is 18 and x square we need to coefficient is 1. So 18 ones are 18. Where this 18 will come, we need to check all those. 1 18s are, 2 9s are, 3 6 are. That's it, right? Now, not to have any confusion, I am taking the constant as only 18 only, but in real minus 18 is the constant. So don't get confused with that one. If the middle number as well as last number both are negatives, I repeat, if the middle term as well as the last term both are negatives, from the pair biggest number should be negative. 1 18, biggest is 18, right? So it should be negative. 2 9, 9 is biggest, right? It should be negative. 3 6, 6 is biggest, right? So it should be negative. 1 minus 18 minus 17, 2 minus 9 minus 7, 3 minus 6 minus 3. But the middle term is minus 3, right? So this last term is correct pair. So x square, that minus 3x we can replace with plus 3x minus 6x. Minus 18 as usual. From the first and second terms, we can take out x common. Then we replace with x plus 3. Now here also we need to get same x plus 3 only. So for that, if we observe the third term is minus 6x. Already x completed, then remaining is minus 6. X plus 3, it is there 2 times. So write 1 time x plus 3 into, here extra is x, here extra is minus 6, x minus 6. X plus 3 is there, so our x value will be minus 3. X minus 6 is there, our x value will be plus 6. So x value is minus 3 and plus 6, or else the zeros of the given quadratic polynomial are minus 3 comma 6. Next, zeros of x square plus 3x minus 18. As usual, constant is 18. We need to multiply it with x square coefficient, that is 18 ones are 18. 18 will come in one table 1 18s are, 2 table 2 9s are, 3 table 3 6 are. If the middle term is positive and the last term is negative, from the pair bigger number should be positive. 1 18, 18 is bigger number, 2 9, 9 is bigger number, 3 6, 6 is bigger number, then smaller number will be negative. Minus 1 plus 18 17, minus 2 plus 9 7, minus 3 plus 6 3. So here also same again, last pair is the correct pair. First term x square as it is, plus 3x we can replace with minus 3x plus 6x minus 18. Now from the first and second terms we can take out x common, then we replace with, remains with x minus 3. Here also as it is x minus 3. Third term is 6x, right? X already completed, then remaining is plus 6. X minus 3, it is there 2 times, so write it once, x minus 3 into, here extra is x, here extra is plus 6, so x plus 6. X minus 3 is there, then x value will be plus 3. X plus 6 is there, then x value will be minus 6. 3 and minus 6 are the zeros of the given quadratic polynomial. Okay, till the previous question, we have quadratic polynomial. By that quadratic polynomial, we found the zeros of that quadratic polynomial. In this case, already zeros are given. By using those zeros, we need to find out the polynomial. So, look at the question. If minus 2 comma minus 3 are zeros of a quadratic polynomial, then find that polynomial. So, whenever if two zeros are given to find out a quadratic polynomial, the formula we will use is k into x square minus alpha plus beta into x plus alpha beta. K is a constant. I will use that in the last one. So till the last step we will write the k as it is only. Next, alpha and beta are zeros of the polynomial. K as it is into x square minus alpha, first 0 is given as minus 2, beta minus 3 into x plus alpha minus 2 into beta minus 3. Let us simplify this now. K into x square minus 2 minus 3 minus 5x plus minus 2 into minus 3 6. So k into x square minus into minus plus 5x plus 6. Now x square plus 5x plus 6, it doesn't have any denominator at all. So whenever if the denominator is not there, simply we can remove this k value. So the required polynomial is x square plus 5x plus 6. Right here clearly if k equals to 1. Why? Because x square plus 5x plus 6, it doesn't have any denominator, right? So if no denominator is there, means we can write this as by 1. So to remove this 1, we will take the k value as also 1 only. So that this 1 and this 1 both will get cancelled. Then finally we will remain with the polynomial x square plus 5x plus 6. Next, if 1 by 2 comma minus 2 are zeros of a quadratic polynomial, then find the polynomial. As usual, writing the formula k times x square minus alpha plus beta into x plus alpha beta. K into x square minus alpha 1 by 2 beta minus 2 into x plus alpha 1 by 2 into beta minus 2. So let us simplify this further now. K into x square minus this 2 I will write it as 2 by 1. So if you do cross multiplication, 2 ones are 2, 1 ones are 1, minus 2 twos are 4 times x plus into minus minus 2 will get cancelled, then remains with 1. K into x square minus 1 minus 4 minus 3 by 2 into x minus 1. K into x square minus into minus plus 3 by 2x minus 1. Here all the derivatives are different, right? So x square I am writing it as x square by 1 and 1 I am writing it as 1 by 1. So all the denominators are different. So we will go with the LCM. LCM of 1 to 1 is 2. In one table where we will get 2 2s are, so multiply with 2. In two table where we will get 2 1s are, so multiply with 1. In one table where we will get 2 2s are, so multiply with 2. X square into 2, 2x square plus 3 1s are 3, x as it is, minus 1 2s are 2. So now here we got some denominator 2. So to remove this 2, take the k value as 2 if k equals to 2. So 2 into 2x square plus 3x minus 2 whole divided by 2. So this 2 both will get cancelled. Then finally we remains with 2x square plus 3x minus 2. This is the required quadratic polynomial.